This is a video going over the 1.9 practice. So question number 1, it gives you a dot plot of 30 major league teams in the 2014 season. And it says the Red Sox won 71 games. So 71 games is this dot right here. And that is the 1, 2, 3, 4, 5, 6. So they are the 6th out of the 30 teams. 6 divided by 30 comes up to be 20%. Okay. Okay, so they're in the 20th percentile. Okay. Part B, the New York Yankees were in the 60th percentile. So interpret that value. It means that the Yankees won more games than 60% of the other teams. Okay, and how many games did they win? So which of these dots up here is the Yankees? So 60th percentile, okay, we want 60% of the 30 teams. Gives you the 18th number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it looks like they won 84 games. Okay. Number 2. Boy in his shoes. How many does a typical boy own? To find out, they surveyed 20 male students, then started recording the number of shoes they owned, and here's the data. He reported owning 22 shoes. Find his percentile. So I think what I'll do first is put them in order. So I'm going to pause the video and put them in order. Okay, I made a dot plot of the data so I can keep track of it in order a little bit more. So Martin is a student who reported owning 22 pairs of shoes. What is his percentile? So 22 is this one right here. So he is it's either a total of 20 students. So this is number 18. So he's number 18 out of 20. 18 out of 20 is 0.9. So he's in the 90th percentile. Okay. Part B, Luis is at the first quartile. How many shoes does he own? Okay, so first quartile is equal to the 25th. Okay, that's 25th percentile. Okay, so 25% of the 20 numbers would be 5. So he's the 5th one in. So 1, 2, 3, 4, and 5. Therefore, 6 pairs is the first quartile. Okay. Okay, question number 3 is a cumulative frequency graph. So the amount of a sample of 50 grocery shoppers at a store. So we keep adding more and more in until we get to 100%, which is all 50 of them. So what is a percentile who spent $19.50? So amount spent, $19.50 would be about here, which would be about the 30th percentile. Part B, estimate and interpret the 80th percentile. So 80th percentile looks like it's about right here, this dot maybe, which is about 50th. $50. Interpreting that means that 80% of the people spent $50 or less. Okay, and there is no part C there. Number 4 displays the cumulative frequency of the length of phone calls made from a math department office at this certain high school. It says what % of calls lasted 30 minutes or more. Okay, Length of call would be here, 30 minutes, and the percentile would be about the 70th percentile. Okay, so 70% would be less but it's asking us 30 or more. Therefore, we would have 30% that lasted 30 or more minutes. Okay, so read that one carefully there. Okay, part B, estimate the inner quartile range. So I'd say quartile 1 is at the 25th percentile. And the 25th percentile looks like it's about 12. I'd say the third quartile is the 75th percentile. 75 would be roughly about 30. Therefore, our inner quartile range is going to be 30 minus 12, which is approximately 18. Now, if you don't get exactly that answer, that's okay, because we're just estimating from the graph, but it should have that idea. Okay. Number 5 talks about the Nationals 2014 baseball season. For all of Major League Baseball, they had a mean of 81 and a standard deviation of 9.6. So we want to know specifically for the Nationals. The Nationals won 96 games. So remember, our z-score is equal to our x minus our mean divided by standard deviation. So they won 96 games minus a mean of 81 over 9.6. So if you work that out, that's 15 divided by 9.6 gives you 1.5625. Okay, so interpret this within context. We can say the Nationals were 1.5625 standard deviations above the average MLB team. Okay, question number 6 says, based on 2010 census, the percent of aged 65 and older in the U.S. has a mean of 13.26% and a standard deviation of 1.67%. Okay, so part A says find and interpret the z-score for Colorado, which is at 9.7. So we'll have 9.7 minus the mean divided by the standard deviation. Okay, so 9.7 minus 13.26, enter, divide by 1.67 gives me negative 2.13. Okay, so it says, and interpret. This means that Colorado what is this? Residents that are 65 or older are 2.13 standard deviations below the average for the U.S. Okay, so it's negative, so it's below. They're below average. Okay, part B says find the z-score for Florida is 2.6, so they're really up there, 2.6 standard deviations above. We want to know, find the percent. So we want to know this number. So this number minus the mean divided by the standard deviation is equal to a z-score of 2.60. Okay, to solve this, I would take both sides, multiply by 1.67 to get rid of the fraction. So I'd have x minus 13.26, and 1.67 times 2.6 is 4.342. And then I want to add the 13.26 over. I get x is 17.6%. Okay, so Florida has 17.6%, which, if you think about Florida, everybody moves there. All the old people move there. So a large proportion of old people. Okay, number 7. According to the LA Times, speed limits on California highways are set at the 85th percentile of vehicle speeds on those stretches of roads. Explain to somebody that doesn't know statistics what that means. Okay, it means that the speed limits are set so that 85% of the people will go that speed or less. Okay. Okay, question number 8. It says, Larry came home very excited after a doctor visit. He announced proudly to his wife, my doctor says my blood pressure is at the 90th percentile for men like me. I'm better off than 90% of similar men. How should his wife, who is a statistician, respond to Harry's statement? Well, that means his blood pressure is higher than 90% of the people, which means that his blood pressure is high, which is not good. He could have a heart attack and needs to go on medication. So that's what that means. Okay, so yeah, high blood pressure is not a good thing, so it's not good to be high there. Another thing where it might not be good to have a high score, like at golf, you want a low score, so if you're in like the 90th percentile in score, that's not good. You want to be in the low percentile on some things. If it's a lower score is better. Okay, and the last question, SAT versus ACT. Okay, this is a good question to think about here. She took both the SAT and ACT. She scored 680 on the SAT. And a 27 on the ACT. Scores on the math section vary from 200 to 800. And the mean, so I'm going to find the z-score for both of these. So the mean, let's see if I can get them both here. So she scored a 680 minus the mean of 514 and a standard deviation, so divided by the standard deviation of 117. That's the SAT. The ACT, she scored a 27 minus, there was a mean of 21 and a standard deviation of 5.3. So on both of these, she scored very well above the average. She scored very well above. But which one did she do better at? Okay, so the z-score is a way to compare things. So 680 minus 514 divided by 117 gives you a z-score of 1.419. 27 minus 21 is 6 divided by 5.3 gives you a z-score of 1.132. So comparing the two, compared to everyone else that took those tests, she did better on the SAT versus the ACT.